Okay, so we have been talking about different forms of factoring, and so now we need to be able to choose the correct factoring method in order to factor quadratics. So the flip chart provided will help us with the choosing which type of factoring strategy. So first, we learned about common factoring, then group factoring, which we also learned about in decomposition with complex, but that's okay. We learned it first in 4.1. Then we did simple trinomial, where a is equal to 1, and complex, where a is not equal to 1. And for this, we did 3 ways: decomp, box, and guess and check. We don't have to be that specific. Sometimes you may feel like one over the other. I'm not too worried about that. And then lastly, the last strategy was checking for difference of squares, which the textbook calls a special case. Okay, so that's what this flow chart looks like. Always, 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 we are looking for a common factor. Then you check the number of terms. If there are only 2 terms, then it is a difference of squares. So in the example here, 9x squared and 16 are able to be square rooted nicely. So the square root of 9x squared is 3x squared, 3x. The square root of 16 is 4. And then, of course, there's always a plus and minus option. So then when you come together, the plus and minus terms, so positive 4, for example, plus negative 4 would give you 0. And that's why the bx term disappears. If there are 3 terms, then you could have a simple trinomial where the a value is 1, and a complex trinomial where the a value is not 1. This is assuming that we have already checked for a common factor. And then grouping, so when you have 4 terms, so this would be an example from 4.1 where you factor the first 2 terms and the second 2 terms, looking for a common factor that applies to those 2 terms only. And then in the second line, creating a common factor that is now a binomial. Okay, so that's more like the steps for decomposition. I'm not going to ask you to fill in this flip chart or flow chart again, but it can help you with figuring out which factor strategy you're going to use. Okay, so right away here we are on this side. We have 2 terms in our first example, which means it's going to be a difference of squares. You could also check, even if you didn't want to think about how many terms there were, you can square root 49 and square root 9 nicely. Even that will work. Then in the second example, we have 6x minus 15y minus 21. That's a z, sorry. And when you take a look at this, it almost looks like C, D, and E, except we have different letters, 6, 5, and Z. So what that means is this is likely going to be a common factor question because you can't do simple trinomial factoring. It's not in standard form. You can't do factor out a common factor first and then even do decomp. So the only thing we can do here is divide by a number term. So as always, try the 6 first. 15 doesn't divide by 6. 21 doesn't divide by 6, so that's not it. But if you do 6 divided by 3, then you would get 2x. 15 divided by 3, 21 divided by 3, gives you numbers that cannot be factored further. So it is a common factoring question. Okay, and then this x squared minus x minus 30 is in standard form. A is equal to 1. So it's simple. It's a simple trinomial. Whereas the next two are going to be not equal to 1. And so they are complex trinomials. In a question like this, it is not a requirement to factor the trinomial, but you could do that to check your answer, but you don't need to. Oh, and then this last one, it's got 4 terms, which is going to be group factoring. Okay, so now when you do a question like example number 2, you are using the flow chart, but you don't necessarily have to write down what kind of factoring you're doing. But if you want, you certainly can. So here in A, oh, we already did this. These are the ones from above. Oh, perfect. Well, let's factor them then. We've already decided that they are, the first one was going to be difference of squares. So when you factor the difference of squares, you're looking for the square root of 49 y squared is going to be 7y, and the square root of 9 is 3. So plus 3 minus 3, and it doesn't really matter if you put the plus or the minus first. In the end, if you do positive 3 times negative 3, you're going to get negative 9. And if you do negative 3 times positive 3, you would also get negative 9. Okay, so that doesn't matter, just like before. For trinomial 3, which is going to be simple. Oh, sorry, B's on here. Oh, and I already did it. Well, that's all right. So we're going to do common factoring, which means we're going to divide by 3. So the 3 goes out front. 2x minus 5y minus 7z. Fix that Z there. And so when you do this type of factoring, yes, when you divide by the 3, then that's what goes out front. That is the common factor. And just take a look at what we have left over, this trinomial here. 2x, negative 5y, and negative 7z cannot be divisible by any letter or number further. Okay? So now we have x squared minus x minus 30, and you can employ guess and check here as well, because maybe now you've done so many of these, two numbers that multiply to negative 30 and add to negative 1. Maybe you don't even need to do 130, 215, 310. Your brain automatically is better at multiplication tables, and you know it's going to be 6 and 5. And we need to get a negative 30 and a negative 1 which means that we are going to use positive 5 and negative 6. Okay, so it doesn't say to check, but even if you did a quick, negative 6 times positive 5 would give you negative 30, negative 6 plus 5 would give you negative 1. You could even just give it a quick check. Okay, so the next two that are complex trinomial factoring, then we are going to use, what I'll do is I'll do D with decomposition, and then I'll do E with the box, just so that you have the two different kinds. Guess and check, I guess sort of goes without saying, but you could you could do that as well, but maybe you don't feel that good yet about guessing and checking. Okay? Okay. So I need two numbers that multiply to AC, which is 36, and add to B, which is negative 12. Okay, so again, 36 has quite a few factors. 136, 218, 3 and 12. So really, even the 3 and 12 isn't going to get us negative 12, but we're getting closer. 4 and 9 is 13. We're almost there. So then 6 plus 6, I have to extend my chart. There's so many factors. 6 plus 6 will give you 12, positive 12. We want negative 12. So we need negative 6, which is going to give us negative 6 times negative 6 will give us positive 36, and negative 6 plus negative 6 will give us negative 12. So when you do decomposition, we're going to rewrite the B term with the two factors. All I've done is essentially unsimplified it, right? I've expanded it. And now we're going to group factor. So I'm going to do the first two and the second two. And remember the trick with decomposition, when you factor the greatest common factor to the first two terms, you're going to create something inside brackets that's what you're looking for in the second term, two terms. Okay, so it sort of gives you a hint. So I'm going to check 4. 6 does not divide by 4, but 6 and 4 are divisible by 2. And there's x in both of the terms, so you can pull out a 2x. And then when you divide, and if you like to show your work, let me see if I can get a lighter color. Okay, so we can show our work. If I divide by 2x, then I am left with 2x. 4x squared divided by 2x is 2x. Negative 6x divided by 2x is going to be negative 3. So that means that in my next terms, that is what I'm looking for inside the brackets. So now you've got sort of the answer. You have to decide if that's going to work for you. So if I want to get positive 2x out of negative 6, I'm going to divide by negative 3. That is going to give me positive 2x as the remainder. And then if I divide 9 by negative 3, I'm going to get negative 3. So it's going to work out. So I'm going to put negative 3 Negative 6x divided by negative 3 is positive 2x. Positive 9 divided by negative 3 is negative 3. And now these two brackets match. So that becomes our common factor. Whoops. And the leftovers, 2x minus 3. Oh, look at that. And so now you can, I don't mind if you leave it like that, or you can write it as a squared. That's fine. Okay. All right, so the next one I will do by box. It is also a complex trinomial, sorry. Okay, so with the box, you have to put the A term in the top left and the the C term, sorry, in the bottom right. And then I should have checked. Can we common factor? No. And then we still need to find the two numbers. So it is really similar to decomposition or guess and check. So the two numbers that multiply to negative 60 and add to positive 11. That's what we are looking for. So 60, 160, 230, 320. We're getting there. 60 divided by 4 is 15. Okay, so if you pause for a second, because it is going to be negative 60, so one of our numbers has to be negative. So if you do negative 4 and positive 15 added, you would get positive 11. So here are our two numbers. When you put them in the box, you have to add an x because essentially we are doing decomposition. And then you're going to common factor the columns above. So 20, the column is 20x squared and 15x. So these two, I'm going to factor above it. So what's the common factor there? 5x. And these two, there really is no common factor, except in this case, because there's a negative in front of the 4x, I'm going to take that out. So negative 1, not just positive 1. And then you do the rows this way. So let's divide out a negative 4x. And negative 3. Okay, so we have 5x minus 1 negative 4x minus 3 And this is sorry, this is going to be, actually, what we'll do, we'll just change the signs. That's probably easier. Okay, so we don't write the term x term with negatives, so I'm going to put 4x plus 3. Quick check, 5x times 4x is 20x squared. 5x times 3 is 15x. Negative 1 times 4x is negative 4x. And negative 1 times positive 3 is negative 3. Okay, so that's going to work out. And then the last one, of course, is more group factoring, but we don't have to worry about finding the factors. They are already given there for us. Now, it's sort of, remember, what we want to do is get the same type of binomial inside the brackets. Okay, so can I divide by 3 in the first two? Yes, I sure can. I'm going to change my color again. And I can also divide by x because there is an x in both terms. And then in the second set of terms, I can divide this time only by 2. So let's see if it's going to give me the same thing inside the brackets. So the first two terms, if I divide by 3x, then I'm going to be left with x in the first set of terms and a in the second term. And then if I divide, well, maybe I should divide by negative 2, right? Get rid of that negative as well at the same time. Okay, I'm going to divide by negative 2, which is going to get me positive x. And negative 2 divided by negative 2 is going to leave me with a. And there it is, the two sets of brackets that are the same. So we can factor that set of brackets out, and then whatever's left over goes in the second set. Okay, so it's really, this is a really good review day. It's essentially just making sure that when it's all mixed together, we are able to factor using the strategies we already know.